Tile prefetching. For a given tile request, tile prefetching methods try to anticipate which tiles will be requested immediately afterwards. There are several works in the literature that address object prefetching in WebGIS, approximate which tiles will be used in advance based on the global tile access pattern of all users and the semantics of query, using heuristic method that considers the former actions of a given user. Metatitle 3x3 centered in the requested tile. We propose another prefetching strategy, known as metatiling, that works as follows. When the proxy receives a tile request from a client and a cache miss is produced, it requests a larger image tile, called metatitle, to the remote backend. This metatitle includes the requested tile and also the surrounding ones contained in a specified buffer, as shown in. Then, the proxy cuts the metatitle into individual tiles, returns the requested tile to the client, and stores all these fragments into the cache, as shown in. The main advantage of metatiling is that it can reduce the bottleneck between the proxy cache and the remote web map server. Tile request flow with metatiling. Moreover, metatiling reduces the problem of duplicating the labeling of features that span more than one tile. This problem is illustrated in. Depending on the WMS server's configuration, this feature can be labeled once on each tile. By increasing the geographic bounding box of tile requests, the WMS server avoids label duplicates. WMS labeling issues. A. Requesting individual tiles yields duplicate labels between adjacent tiles. B. With metatiling, labels are not duplicated. The Analyze Tile Cache implementations, see section, allow users to configure the size of metatiles. For a given request, the cache orders a metatitle of preconfigured size to the WMS server, centered on the requested tile. Considering a scenario where the cache is neither complete nor empty, the selection of the area to generate may not be very efficient, because it is probable that some of the tiles contained in the metatitle would already be cached. Under the assumption that the surrounding area of the requested tile is not uniformly cached, a novel algorithm for the optimal selection of the metatiles to generate has been developed. This procedure, illustrated in, seeks to obtain, based on the current state of the cache, the metatitle that contains the requested tile, but not necessarily centered in it, and that provides the system with the maximum new information. In order to validate the hypothesis that a performance improvement can be achieved by using metatiles, the following experiment has been realized. A total of 2,000 different tiles have been requested to the CORIN, Coordination of Information of the Environment, service. http://www.ing.s/ing/layout, in/corin, land, cover.do proxied by the Musharper tile cache. The experiment has been repeated for different metatitle sizes, always starting from an empty cache state. The mean latencies measured for each configuration are collected in table. http://www.ing.s/ing/layout, in/corin, land, cover.do. The first column of the table shows the mean latency of a cache miss tile m, metatitle for different metatitle sizes. This delay includes the transmission and propagation delays in the network, the map image generation time in the remote web map service, and the processing time in the proxy cache. The values of the second column tau m, metatitle_n are computed by normalizing those of the first column by the number of tiles encompassed by each metatitle, 2. The last column shows the cache gain achieved by the use of metatiling, computed as the average acceleration in the delivery of a tile versus not using metatiling, as depicted in equation. Results reflect that the latency involved in the request of a metatitle increases with the buffer size. However, it increases in less proportion than the number of tiles it is composed by. Therefore, the mean latency to obtain each individual tile decreases when increasing the size of the metatitle requested to the remote web map service. In other words, it is faster to retrieve a metatitle composed by n times n tiles than the n2 tiles individually. Metatitle selection algorithm. A limiting factor when choosing the metatitle size is the overhead and memory consumption required to generate the map image. For example, by default the maximum amount of memory that a single request is allowed to use in GeoServer is 16 MB, which are sufficient to render a 2048 by 2048 image at 4 bytes per pixel, or a 8 by 8 metatile of standard 256 by 256 pixel tiles. Table shows the maximum gain that can be achieved by the use of metatiling techniques. This maximum gain occurs when the whole metitile is used to cache new tiles that were not yet cached. While this is the case when automatically seeding tiles in sequential order with non-overlapping metatiles from an empty cache or in the early startup of the service, it would be useful to evaluate metatiling in the most general scenario where the cache is partially filled. In that case, each metitile is likely to add redundant information, since it is probable that some of the tiles encompassed by the metitile were already cached, thus reducing the effective gain of this method. The performance of metatiling during dynamic cache population with users' requests has been evaluated using the Rumsharpertile cache, described in section. Simulations were driven by trace files from the public WMS tiled web map service of Cartography. Being traces recorded in a real, working system, these logs represent a more realistic pattern of user behavior than a synthetic pattern. The Corin WMS service was used as remote backend. Cache hit ratios obtained for different buffer sizes and metitile configurations. Number of cache tiles for different buffer sizes and metitile configurations. A total of 1.000.000 requests were made to the cache. The experiment was repeated for different metitile configurations. For each configuration, the cache hit ratio and the number of cache tiles after task completion have been collected, starting from an empty cache. Results are shown in AND. As can be shown, both the cache hit ratio and the number of cache tiles grow with the buffer size. For a fixed buffer size, both metatiling strategies, centered and minimum correlation, obtain similar results. However, the number of cached objects is significantly improved with the minimum correlation configuration. The improvement increases with the metitile size. Thus, the advantage achieved with the minimum correlation metitile configuration is that, maintaining the cache misses, and therefore maintaining the number of requests to the remote WMS server, a broadened population of the cache is achieved. These extra pre-generated map image tiles stored in the cache will allow a faster delivery of future requests.